Hello, this is Dr. Christy Patton Lukes, a chemical engineering professor at Missouri S&T. We are doing lessons for process control. These lessons are based on the textbook by Dale Seaborg, Thomas Edgar, Duncan Mellenchamp, and Francis Doyle, and it's published by Wiley. We are working out of the fourth edition, but at this stage of the course, any of the older editions also have very similar information. So now let's get started with Chapter 3, Laplace transforms.
Let's look at solving another second-order differential equation, but this time we're going to be using a skill called completing the square. That again, you did this many years ago when you took that algebra class. So in this case, when I take the partial or the Laplace transforms, because these all have zero initial conditions, it's going to be 9s squared Ca of s plus 3s Ca of s plus Ca of s equals the Laplace transform of the impulse function, and that is 1. And now if I solve for Ca of s, I end up with 1 over 9s squared plus 3s plus 1. All right? Now that doesn't look so bad, except I can't factor it. And if I can't factor it, well, I could do something like, writing an as plus b on top, but I can tell you that a is going to be 0 and b is going to be 1. If you want to try it on your own, you can. So instead, I need to simplify this in a way that matches the formulas that we've seen so far. Okay? And to do partial, or not partial fractions, completing the square, it is very helpful to first step force a 1 in front of the s squared. In that case, this means dividing top and bottom by that coefficient, which is 9. So I get 1/3 s plus 1/9. Next, I'm going to focus on the s term. At this point, its coefficient is a 1/3. Now, if you'll recall, if I have something that is a perfect square, s plus a squared, when I multiply it out, I get s squared plus 2as plus a squared. So I'm going to take whatever is in front of the s, and I'm going to divide it by 2 to get a. In this case, the coefficient of s is 1/3. I'm going to divide that by 2. 1/3 divided by 2 is 1/6. What I want to do is I want to force it in the form s squared plus 2as plus a squared. So my next step will be to add that a I just calculated squared. Now that's not fair, so the only way to do it and still have something that hasn't changed is to also subtract it. Let me show you. So I've cleared myself a little space. I'm going to be adding 1/6 squared, so plus 1/36, and to make it fair, I'm going to also subtract that same amount, 1/36. Okay. Now this first portion is s plus 1/6 squared. And added to that is 3/36 or 1/12. Okay, well, what do I do with that? If you look at the sheet of Laplace transforms and their inverses, you're going to find one entry that is a form similar to this. Let's look more closely at it. So the form that we're looking for is 1 over s plus a squared plus omega squared, and that is the Laplace transform of 1 over omega e to the minus at sine of omega t. In this case, a is 1/6, and omega is the square root of 1/12. You can rationalize that if you wish, or you can just work with it like that. It's fine. Normally, you would probably get a calculator out, right? All right, so therefore, CA of t, I'm going to have my 1/9, just it's hanging out with us, 1 over omega, so the square root of 12, e to the negative t over 6 times sine of t over the square root of 12. And you may not like the looks of that answer, but that is our answer. Let's do one more. Second derivative again, y prime prime minus 6y prime plus 14y equals 14. This time my initial conditions, y of 0 is 0, y prime of 0 is 2. When I take the Laplace transform, I get s y of s minus s times y of 0 minus y prime of 0 minus 6 times s y of s minus y of 0, which is 0, plus 14 y of s, and that's going to equal the Laplace transform of 14, which is 14 over s. And if I solve this one explicitly for s, I'm going to get s squared minus 6s plus 14 y of s, and then I have 14 over s and add 2. Okay. Well, that means that y of s is equal to, let's make these a common fraction, 14 plus 2s over s, and divide through by the other. So I have 14 plus 2s divided by s squared minus 6s plus 14. All right. Now, in this case, I'm going to, oh, and an s. I forgot the s. Heavens. Okay. I have partial fractions. Okay. There's my partial fractions. And if I let s equal to, well, let's go through and multiply this out. So I have 14 plus 2s equals a times s squared minus 6s plus 14 plus bs plus c times s. If s equals 0, then I have 14 equals 14a plus 0. So a is equal to 1. So far, so good. Okay. And then you can complete this in other ways. This one isn't too hard to multiply out. So if I do this, I have 2, looking at my coefficients of s and my coefficients of 1. 2 is negative 6. Plus c. And my coefficients of 1 And a coefficients of s squared. I guess I have. Okay, so s squared is 0 equals a plus b. Constants are 14 equals 14, and that's it. Okay, so this one's not very useful. This one tells me that c is going to equal 8. And this one tells me that a is negative b, so b is negative 1. All right, well then, that's wonderful. It's not really what I was hoping for. I wanted some of these things to like drop out and be 0, right? So minus s minus 8 over s squared minus 6s plus 14. Okay, well, I'm stuck still with something that's not factorable. And so I'm going to do complete the square. Now this one is a little easier than the last one we did. It's whole numbers, not fractions. So I want you to pause and from this point, see if you can work this independently. So pause the video. Okay, hopefully you found that a was negative 6 over 2, so negative 3. And a squared is 3 squared, so 9. And I am going to, therefore, s minus 8 stays the same on the top. I'm going to have s squared minus 6s plus 9, and then minus 9. So be sure that you do both places. Y of s, therefore, is 1 over s minus s minus 8 over s minus 3 squared for the first group. 14 minus 9 is 5. Okay. A is equal to 3, or minus 3, and b is equal to the square root of 5. All right. Now, if you match these forms, the s minus 8 is sort of a complicating thing because there are two different things, one for the sine and one for the cosine. Y of s is 1 over s minus s minus 3, s minus 3 squared plus 5. I've matched this shape here with this, as the formula shows on the sheet. And then I have s minus 3, I still have the minus 5. So minus minus 5, so 5 over s minus 3 squared plus 5. Now, if I go and match these to the sheet, I find that y of t is 1 minus e to the 3t cosine of square root of 5t plus square root of 5 e to the 3t sine square root of 5t. Okay. Now, if you have any questions at this point, you probably need to do some more practice, but also be sure to ask questions. Okay? This isn't, the most fun thing, but practicing this and getting to where you are pretty decent at it is going to be just helpful for helping you with recognizing patterns, which is where we're going to be going soon. Not going to be taking a lot of Laplace transforms, but recognizing the patterns. Okay, that concludes this video lesson. We'll have one more to wrap up our understanding of partial fractions and Laplace transforms. Thank you.